Today we're going to do 9.11, the exterior angles. We did interior angles yesterday. Now we're going to follow it up today with the exterior. Vocab, a polygon, we talked about that. A polygon is a closed shape with sides that are segments, lines. They have to have vertices. It has to be a closed circle. Or no circles are involved because they have curved lines. It has to be a closed polygon. So like that would not be a polygon because it's not closed. You have to have vertexes and all the vertices, all the corners. The interior angle of a polygon, that is what we learned yesterday. That's an angle inside of a polygon. And now today we're going to be talking about the exterior angles of a polygon. That's an angle outside of the polygon that is formed by extending an interior angle out. So if you look over here, all these red dots on the inside, those are your interior angles. And then if you extend an interior angle on the outside of the polygon, then all these blue ones are your exterior angles. Draw the exterior angles on the following polygons. So you're going to want to grab your line here, and what you do is you extend. You could go that way if you wanted. This way. Give each one of them an extended exterior angle. Except for there's two that are wrong on that one. Because which way do you go? You go to the left, you go to the right. Well, I'll show you. On this one right here is correct. Because of this angle right here. This one, however, not so correct because I don't have a flat line here. Okay, so that one's not right. This one would have to come out this way. So we would have the flat, straight angle here. Now this one, wrong, because we'd have to come out this way. So we have a straight angle. Now we could have also come out this way off of this line to make a straight angle, okay? Or this way to make a straight angle here. Or we could have gone this way to make the straight angle here. But you can see where these are not correct because it does not make a straight angle with your interior angle. Right? Kind of hard to goof up on a rectangle. You go that way, so we have our straight angle. This way, you can make a straight angle. Kind of looks like a pinwheel if you keep going in this direction. Alright, that's one way to do it. Now this one, I could go straight off of this line or straight off of one of these. Extend a line out. There we go. Hexagon, follow the line out, follow the line out, and there you have it. Exterior angles of your polygon. The diagram here is a triangle with one exterior angle drawn. The exterior angle in this case is the 2. The 1 is your interior. So what I was just talking about on the previous page, measure of angle 1 and measure of angle 2 form a straight angle. Therefore, they have to equal, these two angles have to equal 180 degrees. So we can conclude that the measure of an interior plus the measure of the exterior equal 180 degrees. Now they want us to find the value of x, y, and z. Well, first of all, x. So we just learned that these two are supplementary. They form a straight angle. They have to equal 180. So you would take 180 degrees minus 65. All right, and then you end up with your angle x in this case, because that's what we did first. So angle x then would be 115 degrees when you subtract. Now let's do y. 180 minus 75 degrees, you end up with 105 degrees for y. And then finally, let's do the z. 180 minus what? What do I know? I don't know anything on that part yet. However, I do know that the three interior angles of a triangle, we learned that yesterday, equal 180. So if you take 180 minus the 75 minus the 65, what do you end up with? You end up with 40 degrees. Right, so this one would be 40 degrees. Add these all up, 180 degrees on the inside. So now we can take our 180 degrees, now we know the inside, minus the 40. So we know this exterior angle out here, 140 degrees. Now find the sum of all three exterior angles. Take all these exterior angles, add them up. When we add those up, we get 360 degrees. Sound familiar? That is a circle. That is the degrees of a circle. So when we add up the outside, all the exterior angles, if they don't add up to 360 degrees, you did something wrong. Okay? They have to equal 360 degrees. Look at this diagram. This is a pentagon with its exterior angles drawn in. And as you can see, as the pentagon gets smaller, the exterior angles coverage towards the center point, or converge towards the center point, so that the exterior angles form a full circle, which measures 360 degrees. You see, as it progressively gets smaller and it converges towards that center, it makes that circle. So what if there was a hexagon, 6 sides, or an octagon, 8 sides, or a triangle? Does the number of sides change this property of the exterior angles converging to a center point and forming a 360 degree angle? Let's try it. All right, so if we were to go to this, 1, 2, 3, 4, 5, 6, there's this hexagon. If we were to keep going and draw all these angles, exterior angles, and keep going and going and going, does that form a full circle? Let me show you a live example of that. There's that hexagon. And there, as it converges towards that center point, you can see it makes a circle. So all those exterior angles, as that converges, forms that circle of 360 degrees. All right, so that was the live version of that. So it doesn't matter how many exterior angles you have. It doesn't matter if you have an octagon, a decagon, anything. They always have to add up to 360. So let's find the missing exterior angle of this polygon. There's a couple ways you could do it. You could take your calculator and subtract 90, 38, 35, 80, and 40, whatever's left over. That's the remaining exterior angle. Or you can go and you can go 90, 38, 35, 80, and 40. Add those all up. All right, and that would be 283, I believe. And then you would take 360 degrees down our outside circle, subtract this 283, and you would end up with 77 degrees. So, and especially on your tests and quizzes, you should always check your work. Add up all your exteriors to make sure they add up to 360 degrees before you go on. Okay, the last example. Now, interesting. Let's look at what we know about this figure, about this polygon. They want us to find the x. So we need to find the x. And that is an exterior angle out here. X right here. Now, how many of the exterior angles do I have? I have this one, I've got this one, this one. Oh, but wait, that 80 is an interior angle. And I have this x that we need to find, so kind of I need to find two of them. But before I can find x, I need to find this exterior angle, which is very simple, because what does this make with that interior? 180 minus 80. That tells me now I know that this outside angle is 100 degrees. That exterior angle is 100 degrees, because this plus 80, 180 to make that straight angle. Now I can take my 100 degree, this one, my 120, and my 55, add those up, I'm going to get 275 degrees. That's those three. Now I'm still missing the 1, so now I can go 360 degrees, subtract that 275, all right, and you end up with 85 degrees. That is our missing exterior angle. And again, before you go on, especially in tests and quizzes, add these up. 100, 85, 55, 120, yes, 360. They have to be 360 degrees or you did something wrong. All right, your homework for tomorrow, you need to do pages 3, 4, and 5 for 9.11 for exterior angles. Pages 3, 4, and 5.